Yeah. Today is the last day of our math modeling class. In this semester, we have covered mathematics for big data and machine learning. And we have covered materials up to here. And we started from the syllabus, and I introduced your the content that we have covered before, including the mathematics for big data lectures, and also the prerequisite and background for mathematics for big data, including pre-calculus and calculus and linear algebra and statistics and engineering mathematics and graph theory as well. And also I gave you the lectures on mathematics for big data, so you can offer, and also you can use. And also I gave you the list of lectures on introduction to mathematical modeling, and some other reading materials. And you went through this, and then we started the mathematics for machine learning, including the matrix diagonalization and inner product space and truncated singular value decomposition and some of the functional analysis. And we had a midterm exams that includes your midterm PBL report and project proposal and your own presentation on those works. Then we studied the matrix decompositions, including LU decomposition and Schur's theorem and QR decompositions, and some other extra lectures. And then we had the presentation on the project, on your project proposal, and we covered the neural network and support vector machine and K-nearest neighborhood and K-means clustering. And also, the Mr. Park Boyoung gave a final the presentation of his project and final PBL report. Okay, so today, we will continue your presentation of your final PBL first, and then your final project. Okay, each of you will have about 25 to 30 minutes, and LKHAGVA will start first. Okay.
Number of
Introduce yourself first.
my current participation is 55. Here I will show one example in Q&A. Here I try to summarize about Jordan canonical form.
Mike.
Every matrix is diagonalizable, then everything is easier, but all is not diagonalizable. However, every matrix has Jordan canonical form, which is simple upper triangular matrix. Jordan canonical form is right like this, and every GI is looks like this. And here is also I try to how to find the Jordan canonical form using dot diagram. And professor asked me, so you know, can you explain how to find the GCF? And I try to answer it this. There is 4 steps using dot diagram to find Jordan canonical form, and here is one example to find Jordan canonical form. My PBL report contains first I summarized some concepts what we learned so far. First week, in first class we just started our class with basic information about our courses. We discussed what we will cover in this whole semester. We discussed about basic mathematical concepts which will be needed in this semester for this class. Also, we learned how to solve problems with Sage in this week, first week. Second week, we learned this fundamental theorem of algebra and calculus dual space of a vector space. And here as I summarized some concepts of and definition and some properties. Also, third week, we learned this and I summarized some concepts here. Fourth week, we also learned singular value decomposition, pseudo-inverse least square solution, Cashew sequence, Banach special pretty space operator, and matrix norm. For example, here are some concepts I summarized. And sixth week, we studied big data and science, how to apply LKHAGVA, deep learning, and math for big data. And I summarized math for big data, LU decomposition, short decomposition, forward method, covariant decomposition, Google PageRank algorithm, singular value decomposition, and principal component analysis, graph and matrix. I summarized all concepts. So, ninth week we learned triangular matrices and LU decomposition, L2U decomposition, Cholesky decomposition, also unitary and Hermitian matrix, diagonalizable and normal matrix, short decomposition, dominant eigenvalue, eigenvector power method, and inverse power method. Here is some concepts of, and here is also concepts power method, and 10th week we learned Grammat suites, normal processes, and coord decomposition. And here is also I summarized. 11 is also neural networks. And 12th week we learned support vector machines, and some concepts I summarized here. Next, I will include it here as my Q&A participations here. First, I include in Q&A example calculus and linear algebra problems. Second is I try to understand the SKKU matrix calculator and some Q&A comments here. Also, I sign up the Sage netbook account which can be used during this class. ID is this, password is this. Also, here as I studied to how to find Jordan, I introduced before this comment, and also I try to understand the matrix function and polynomial. Then I included the Cayley-Hamilton theorem in Q&A, and professor uploaded it is proof, how to prove this. Also, I tried to summarize the ebook, the Jordan canonical form, here is about. Here is all. This is okay.
Continue.
Q&A past participation is I included, and address is discussion about, for example, here Professor uploaded sample of math modeling project, and it is very useful for Pak Bo-young and me. It contains main concepts of graph theory, and one can easily understand the concept with it. Math modeling project, graph theory, and also here is given a random vector, the probability distribution of all its components considered together is called joint distribution, while the probability distribution of one of its components considered in isolation is called marginal distribution. Here is discussion of marginal distribution. And I have found quant past participation is here. And I also uploaded summary of machine learning courses, an attachment file, and this is LU decomposition, short decomposition, and graph and matrix. Here is always current past participations, and here is about my project subject and discussions with the professor. Uploaded some materials, and here is I uploaded least square solution with example, this example. Here is also in R codes for clustering analysis, this data set. I included this data set in my project, this data. Cummins algorithm is like this, works. Conclusion. First of all, I would like to thank bigger. Up to 150. First of all, I would like to thank to our professor that given us an opportunity to take this course. As the result of choosing the class, I have learned various mathematical concepts and their application, which can be useful for the future research. Especially, I have obtained to know more about matrix. I didn't know it before as deeply. As professor directed us to exchange my newly learned topics in Q&A, it was really beneficial for all of us. And then by using iCampus system, whenever I face problems about any subject, I put them to Q&A and ask them with address. Also, I can read other students' reports and share my ideas with others. Doing it, I have gotten to know more and more. I think this PBL report is a good way to check myself, how much I did in this month. If nothing I did, I will feel not good when I'm doing this report. That is the way to make myself more and more activity, and then I will try to learn more things and obtain more things after this report. Final project. Motivation. Clustering analysis finds clustering is useful for exploiting data and one of the most widely used techniques. And in particular, the spectral clustering is most popular and widely used. It can be considered as a powerful tool. First two parties I have introduced it before.
So what was the title and the objective and motivations of your role? Yeah, no, title and your motivation more clearly.
Title is Big Data Analysis and Directed Spectral Graph Technique. Directed Spectral Clustering. First part.
So what are you going to do? What's the final goal of this project?
I mainly focus on studying this paper, which proposes the general framework learning from labeled and unlabeled data and directed graph and papers listed in references. First, I study in section 3. These parts I already introduced this part, and next I will study ratio cut criticism for undirected graphs. Today I introduce this part, and also I spectral clustering and directed spectral clustering and difference between them will be considered. Then I will study the spectral clustering algorithms and how it works. First two parts I have already introduced before. First part is regularization framework. This is main problem is this, and next part is directed spectral clustering, and main result is this algorithm, how it works. This directed spectral clustering is. Today I will introduce clustering as graph cuts.
Go slow. You have about 20 minutes.
We have a given data set D, and we should construct similarity graph. It is the similarity matrix is adjacency matrix of the graph and denoted by A. And this is symmetric and non-negative. This means this and this satisfies. And similarity graph is denoted by G equal VE. V is vertex set and E is edge set. Whereas the matrix may be considered weighted adjacency matrix. Maybe for the vertex XC, let the denote the degree of the vertex defined as this formula, and degree matrix is diagonal matrix. Diagonal entries is DE. It is difficult to choose the similarity matrix. One of the creating the good similarity graph, corresponding similarity graph is k-nearest neighbor method. It is common to use the Gaussian kernel to compute similarity between objects using this formula. XC and XG is belong to it is k-nearest neighbor. Then we can construct this formula similarity matrix, where NK is the k-nearest neighbor of XG. Here is Laplacian matrix is defined as this, and normalized asymmetric Laplacian matrix is defined as like this. Also, it is interesting to note that L and L are asymmetric and positive definite matrix, and 0 is its eigenvalue, and corresponding eigenvector is this. If the graph is disconnected, then the number of eigenvalues equal to 0 specifies the number of connected components in the graph. Here is graph a cut, egg-way cut. This cut is the partition is set of vertex set of given as this, and any Ci intersection and Cj is empty, and this satisfies then partition set. It is WST is the sum of the weights and all edges with one vertex in S and the other in T. This formula is this, and S bar is denoted by a complementary set of vertices. This means this. The volume of cluster C is defined as this formula, and this is equal to this and this. Also, cluster indicator vector is defined as this. Then we have some equality this and this. The arithmetic cut is minimization of this sum. This sum is some calculation. We can get the minimum value is like this. Then we can get the spectral clustering algorithm. First we have data set D. Then we can construct, using this formula, construct similarity matrix using this formula. Then we can easily get degree matrix and Laplacian matrix L. Next we compute few smallest eigenvalues of L. Then we should choose the number of K of clusters. Then after that we can easily get our results. For example, here is one example. Data set is looks like this, and we first calculate the similarity matrix of this, and this is this, and also we here we 15 nearest neighbors method used this. Then we get this result. Here first 3 eigenvalues very small, so we should we should choose K is 3. Then result is this. But we can also K is 4. Then the result is also good result. 4 is here at 4. First, the smallest eigenvalue is this. So there is difference. If there is big difference, then we should K is 3. We should choose K is 3. Then is good result we can get. Also, I have this right?
make it pause until you start.
Pause.
Pause. Pause. I mean here. Okay, pause.
This example is this. If we change this 15 is maybe here as we change this result 5, then the result is 5 is here, and the diagonal matrix, Laplacian matrix, here is eigenvalue. Then first eigenvalues, there is big difference, so we should choose k is 4. Then the result is this, but it's not good result. Then we should choose this number is very important. How to choose this? We should think about how to choose this number. Then 15 is good number. This is for this example. Next example is this data. I don't know this. This data is it. Then we can get I prepared this. First got this coffee. Desktop, my data. Then next step is this. Then the data set is, and next part is this coffee. This data. This is similarity matrix. Next similarity is here as we 3 neighbor good method using this copy. Then this similarity matrix is like this. Next diagonal matrix, and Laplacian matrix. Copy Laplacian matrix. Eigenvalue of Laplacian matrix like this. So we should k is 2. We should choose. Then k is 2. This works. This is first part. This is second part. If we choose the number.
Those data comes from where? Venezuela? Or what was it?
Comes from this site. Professors suggested me.
Yes. What was the data it comes from?
Comes from this. I have found the population by countries.
Dominican Republic.
This
And
this years, and is from this.
So whenever you have a data, then you can analyze the LKHAGVA data.
Here is one more good example. Here is data set is like this.
Okay.
Then our similarity matrix is like this, and diagonal matrix, Laplacian matrix, and eigenvalue is this. So there is big difference, so we should choose case 2. Then last result is, this is first part, this is second part. The spectral cluster using this. Conclusion. Spectral. A little.
Just move that. I like it.
Spectral clustering can solve very general problems like intertwined spirals. Moreover, spectral clustering can be implemented efficiently even for large data set, as long as we make sure that the similarity graph is sparse. However, it is difficult to choose a good similarity graph, and spectral clustering can be quite unstable under different choices of the parameters for the neighborhood graphs. So, spectral clustering cannot serve automatically detect the correct clusters in any dataset, but it can be considered as a powerful tool which can produce extremely good results if applied with care. The process is this.
What was the main differences that you
Main differences is this last process.
What was it? Coming from
Also, I should use I use it whereas spectral clustering theory and normalized cut. This. This is main differences.
Okay, so yeah, LKHAGVA gave a presentation on his PBL report and a project. So we will continue for Mr. Lee's. Okay, and before we go for the next presentation, and each of you gave questions and comment, and LKHAGVA answered on those questions and comment. Okay.